Hopefully by the end of this lesson you'll be able to use similarity in order to find side lengths, altitudes, hypotenuses, long legs, short legs of triangles. Specifically, these are going to be right triangles. Down below we can kind of see that we have a special grouping of triangles. These are, if you have one right triangle and you drop down the altitude to the hypotenuse, it actually ends up creating not one but two additional triangles. And these three triangles, the blue triangle, the red triangle, and the large black triangle, are all similar. Most of the time I will call this the small triangle, the medium triangle, and the large triangle. I think it kind of reminds me of ordering pizza, either a small, medium, or large. And the idea is that the small is similar to the big. The medium to the large, similar. The small to the medium, all similar. And we'll talk about writing similarity statements, as well as using this similarity to write all sorts of ratios to find different pieces, such as the altitudes or one of the missing legs. The directions say write a similarity statement for the three similar triangles in the diagram, then complete the proportion. We'll start this off in a really specific way. We'll just talk about the small triangle to the median triangle to the large triangle. I'll call it the large triangle. So to start off with, this is going to be a triangle. I'm going to name this in a very systematic way. I'll just start with the short leg and move along the long leg. So this would be triangle DGE. That's going to be similar to, in the median triangle, this is the short leg is EG and the long leg is GF, so we'll write it that way. And for the large triangle we would say DEF. And again, the way that I'm doing this is in a very systematic way, because this has a very specific meaning that D and E are going to have the same angle and E and D are going to have the same angle. There is a relationship that exists, and this needs to be written in a very specific way. So be careful when you're writing these. Also, if you notice, angle G is the right angle in this small triangle, angle G is the right angle in the median triangle, and angle E is the 90-degree angle in the big triangle. Okay, so I named it in a very specific way. Now I can talk about, I don't know what that was. Now I can talk about the ratio that exists and try to find the missing piece. So if I talk about DG and something related to GF, here's the method that I like to use. There's a lot of methods that are out there. I like to use what I call the box method. Okay, what the box method does is it allows you to look at these pieces, determine what triangle this deals with, look at this piece, decide what type of triangle it deals with, after writing sort of what pieces we have. So this is up top, I'm going to write what triangle I have, either small, medium, or large. And on the side I'm going to write what pieces I have, such as long leg, short leg, or hypotenuse. So for me, DG and EG both exist in this small triangle, so this is representing the small triangle. The DG is the short leg in the small triangle, and EG is the long leg of the small triangle. Now I look at GF. GF is the long leg of the median triangle. This is GF right here. This is the median triangle, so that means that I need to look for the small leg, which is going to be either EG or GE, will be the short leg of the medium triangle. Okay, why don't you guys try the similar process? First write a similarity statement for the three triangles, then identify the missing piece in each of 2 and 3. Welcome back. Hopefully you found the missing pieces. This would be NQ is the missing piece, and over here RS is the missing piece. If you have questions about that, make sure to let me know. Next, what we're doing is we're going to find the value of the variable. This can be done in many different ways, and the method I am going to again prescribe is the box method. With the box method, we just set up two ratios that exist here. I'll look up here and I'll see, hey, this small triangle right here has two quantities. I'll just say 2W over 3W. From that, what I'll do is I'll identify, well, the 2W is definitely a short leg, the 3W is the long leg of the small triangle. I'll then come over here and say, okay, well, in the medium triangle, I also have these quantities. 3W is my short leg, and my long leg, that's going to be this part here, this 4W plus 3. What I'll do now is I will actually cross multiply with this ratio. So that'd be 2w times 4w plus 3. And that's going to be equal to 3w times 3w. Okay, this becomes 9w squared. This becomes 8w squared plus 6w. I'm then going to move everything to the right side. So that'll be 0 equals, that'd be w squared minus 6w. Once I factor here, I would have w minus 6 and w. I'll then say that w equals 0 and w equals 6. This is using the zero product rule, that one of these two quantities has to equal 0, if not both of them. I look up here though, I want to check my answers. W equals 0 will make a length of 0 here and a length of 0 here, so I had to toss that guy out. That does not make sense. A length of 6 will work though, so I'll keep that one. Why don't you guys try this with the next one, a little bit more complicated, 8 and 9. Quickly, I'd like to go through number 9. We're just going to draw a box here, and there's a couple different ways you can do it, and yet you can set it up. I just want to set this up quickly. We'll talk about the medium triangle, and we'll talk about the short leg over the hypotenuse, just to show that this could be done in a slightly different way. The short leg is going to be a plus 4. The hypotenuse then is going to be 2a minus 4. The short leg of, say, the large triangle is going to be 2a minus 4. And then this piece down here is going to be 2a plus 4 when we add both these pieces together. At that point, I'll cross multiply, so that I have to have probably a little bit of room. A plus 4 times 2a plus 4. That's going to equal 2a minus 4 times 2a minus 4. I'll then multiply this out a little bit. I'll have 2a squared plus, let's see, that'd be 8 plus 4, so plus 12a plus 16 is equal to, when I FOIL this, I'll get 4a squared minus 16a plus 16. I'll then, because I always want to have my a squared with a positive, I'm going to move these to this other side, so everything is going to go, again, to the right side. So this will be 2a squared. That'll be minus 28a equals 0, I guess. The 16s cancel out. At that point, I'll take the opportunity to factor. I'll say 2a, and that'll give me a minus 14. That all equals 0. That means that either 2a equals 0 or a minus 14 equals 0. If I divide by 2, I'd get a equals 0. If I add 14 to both sides, I'd get a equals 14. If I was to put a up here, that'd be a 0 up here, and for a, that's going to be a problem, so I can cross this guy out. A equals 14 is going to be the only answer that's going to work out. For the number 8, just so that you know your answers, you again get y equals 3, y equals 0, and again y equals 0 will not work because of this part right here. Okay, the book wants to give you some shortcuts. If you use the box method, these two shortcuts do work. I encourage you to take a look at these. This one's a little bit easier to take a look at. This is a little bit more complicated with it. I think they do make sense. They do work. I'm going to continue using the box method, but I just want to show you that this is a shortcut to the box method. We'll notice that BD and CD are both components. BD and CD are both components of the small triangle. CD and AD are both components of the medium triangle. So if I drew my box right here, this would be my box. This is just going to be comparing the short leg to the long leg is my ratio. So basically comparing this guy to the medium, or the altitude, I guess, and this guy, or the altitude to that guy. So it's just going to be short leg to long leg is the ratio. This ratio is a little bit different. This part over here, if I just look at sort of the right side of this, is going to be the large triangle. This is the medium triangle. Slightly more complicated. It's going to be hypotenuse over leg, long leg, in order to give us this ratio for our box method. Just shortcuts that if you see them and notice them, it's a nice way to use this. Either using the geometric mean altitude theorem or the geometric mean leg theorem. A little bit more complicated, but useful if you notice them. I want to take a look at these problems, just a little bit of them, just to kind of give you a glimpse at what some of the more challenging problems could look like. You could use the geometric mean theorems, but if you do not remember these 2 or 3 years down the line, I want to show you a couple methods on how to solve these differently. So I noticed that this is 16 and this is 30 of the big triangle. It'd be really nice if I knew this third side, this hypotenuse. So I'll just say that, you know, AC squared is going to equal 16 squared plus 30 squared. Using the Pythagorean theorem, I can figure out that AC equals 34. So this entire length right here is 34. I'll then set up a ratio using the box method for the small triangle. If you notice in the small triangle, I'm trying to find BD, so that's going to be really useful because that's one of the things I'm looking for. So I'll say BD over, we'll say 16 because that's the only other piece that I know in this triangle. So that's going to be talking about, let's see this, that's the long leg over the hypotenuse. Now I need to pick something else. Since I have all three components in my large triangle, I don't know how I'm spelling large. In the large triangle, I'll just use those. So the long leg of the large triangle is going to be 30 over 34 is the hypotenuse. At that point, I can just cross multiply and solve a very straightforward problem. I think it's a little bit more complicated with this guy, but I think it's the same method. The idea is first you're going to solve for AC because you have in this triangle right here, you have two of the three sides. So I want you to find the third side. Once you have all three sides of any triangle, all you do is you go and look at what else do you need to find. Notice that you have one piece of this triangle, and you can easily set up this piece of the triangle here. For instance, you would find that AC equals the square root of 30. That's just using the Pythagorean theorem. A little bit more complicated because we have radicals involved, not a huge deal. You would then have your small triangle and your medium triangle using the box method. And what it looks like is we would compare the hypotenuse to the short leg. So that'd be 5 square root of 3 over the square root of 30. And that's going to be equal to BD, which is the last thing we're looking for, over 3 square root of 5. In the end, after you cross multiply, simplify, 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 and simplify some more, you probably get somewhere around 15 square root of 2 over 2. I had some people get slightly different answers for BD, probably because it's hard to tell whether this is the small triangle, whether this is the medium triangle, whether this is the long leg, the short leg, or the hypotenuse in comparison to the other sides. This is a pretty tough problem to work on. I try to make this a little bit more clear when we take a quiz or a test on it, so just so you know. Lastly, I want to look at some kind of tough problems. It says, first off, the first thing you want to do is you want to tell whether the triangle is a right triangle. And we know how to do that just using the Pythagorean theorem. Basically, and if we get something equal to it, it's going to be a right triangle. If so, find the length of the altitude of the hypotenuse. Round your decimal answers to the nearest tenth. Let's give this a shot here. First off, we would say 3 times the square root of 61 squared. We're asking, does that equal 15 squared plus 18 squared? It does when we calculate this whole thing out. It does. So we do know that we have a right triangle. That's really good. In fact, for the second one, we also have a right triangle. For the third one, no, we don't. So when you're done with this one, once you figure out that it does not work, you can actually stop. For 10 and 11, we would have to continue working. From there, what I want to do is actually want to draw my altitude. And this is going to be pretty tough depending on the orientation, but I would encourage you, oh, this is really not working well, to actually turn your paper sometimes and to actually draw this so that you can actually see this really easily. That does help you to find what the small triangle is, what the medium triangle is. It also helps you figure out, okay, that's definitely my short leg, that's my long leg. This right here is my short leg, this is my long leg, as far as when you're working with the triangles themselves. So if you take a little bit of time and actually work the problem out, I think you'll do really well. I want to call this part here X, this altitude of the big triangle, or just this dotted line that I had to draw on here. And what we're going to do is, since we have all three components of the large triangle, what we'll do is we'll compare the large triangle to either one of the other triangles that contains this missing component. So let me just use the medium triangle just because. We could also do this with this small triangle, it would be just fine. So for the medium triangle, I definitely want to use x, and the only other number I have in here is 18. X is the short leg, 18 is the hypotenuse of the medium triangle, so that's the comparison I'll use. So I need to find the short leg of the large triangle, which is 15, and I'll use the hypotenuse of the, I'm sorry, the hypotenuse is not 18, it's 3 squared of 61 of the large triangle. At this point I'll cross multiply, and this is kind of weird to write down, but 15 times 18 gives us 270. This would be 3 times the square root of 61x. I don't know how to write this necessarily, maybe something like this would be appropriate. When we divide both sides by 3 times the square root of 61, luckily this tells us to just round your answers to the nearest tenth, and we would get somewhere around 11.5 as our final answer. Okay, we're working on these just a little bit complicated. I think this is really hard stuff. So I'm glad that you've taken the time to review this and to work through it. Again, you can review these two formulas, these two theorems. I think they're useful. I think having a number sense and just problem solving skills helps even more in the long run. Typically, problems will not involve all this really heavy foiling and then factoring and then doing all this stuff. Problems will not necessarily be that complicated, but I wanted to show you about how hard they could be so that you can adjust and make sure that you're working. Again, we're working with special right triangles, and hopefully you can use them now to find side lengths.